Good morning. So we'll continue with this question. Okay, yesterday we calculated the first two parts. Now today I have just given a third part that calculates the variance of the accumulated amount in the question above. So if you remember, we calculated the expected accumulated amount and accumulated value at the mean rate of returns. So for the first part, we calculated expected accumulated amount. For the same thing, we have to calculate the variance now. So our accumulation factor for 5 years would be 1.06 raised to 5, 1.08 raised to 5 and 1.1 raised to 5, and the probability of that happening is given. We used this to calculate expected value yesterday. I'll do that again, and this was our expected value. Write the formula here, or just write down what we did here. Okay, now if you want to create the variance, okay, so we'll calculate expected value of accumulation factor square. So this will become 1.06 raised to 10 square of the value, but the probability will not be squared. Okay, the value will be squared but not the probability. Variance Now this has to be multiplied by 5000 because the amount is 5000. But always remember that if I take out a constant from inside the variance, then it becomes constant square. So I want now variance of 5000 accumulated from 0 to 5. This is what I want. So that becomes 5000 square variance of accumulated from 0 to 5. Okay. So the value that I'll multiply would be 5000 square. Always, if you have, if you are representing the variance, instead of writing this whole number, you can represent it as a square of the value. So you'll take root, and I'll say that is 4745.28 square. So you are representing the standard deviation square. This is just a standard way of doing it. Okay, this is how we'll find the variance of the accumulated value. Okay, any problem here? Now this was a fixed rate model. So if you remember, yesterday we said we are talking about simple models. We are talking about simple models. In that we had two main types of models. We had fixed rate model that is what we were studying right now. The second was variable rate model. In the fixed rate, we studied two ways of calculating the accumulated amount. We said either find the expected accumulated amount or find the accumulated value for J, that was expected rate of interest or mean rate of interest. These were the two ways we calculated the accumulated amount for the fixed rate model. Now what's a variable rate model? In fixed rate model, we said once we fix the rate of interest for the complete time period n, the rate of interest did not change. But when we talk about variable rate model, each year the rate of interest will keep on changing. So variable rate model. So if I say that our investment is for n years, okay, our investment is for n years. Now each year the rate of interest would be different. So I1, this is the rate of interest that we'll have for the first year. For the second year we'll have I2, for the third year we'll have I3, and so on. For the last year we'll have IN. So we are seeing each year the rate of interest will differ. Now we'll, because we are trying to learn right now how to create these models, so we'll have some constraints. So we are going to assume that let the rate of interest in each year be IID. Okay. So in CS1 we studied what is IID. So IID is nothing but independent and identically distributed random variable. Okay. Random variable. So we are saying that the rate of interest for each year is different and unknown. Okay, so the rate of interest in each year is different and unknown, but they are independent and identically distributed random variables. That means that I2 is not affected by I1. Similarly, any year, I3 is not affected by I1 and I2 because they are independent of each other, but they are identically distributed. That means they come from the same set of rates of interest. So yesterday I talked about mutual funds, right? In a mutual fund, their aim is to keep the risk level exactly same. So when I say that I have a mid cap mutual fund, okay, if I have a mid cap mutual fund, that just means that we are expecting a mid range of what do we say, risk. So mid level risk. Okay. We'll talk about how do we calculate risk, and that's part of our course, so don't worry too much about it. Right now we'll say it's a mid level risk. Okay. Okay, so it's a mid level risk. Now when we say that we are trying to maintain a level of risk, so we don't want the risk to be very high, we don't want risk to be very low, we are trying to maintain the mid level risk. The main reason is because when we are creating a mutual fund, that means which stocks to buy, where do I invest in fixed deposit, how much gold bonds I should buy, how much other company bonds I should buy. So by creating a diverse portfolio, we create mutual funds, right? So we are saying we are trying to keep mid-level risk because we'll say that the stocks are very volatile. We have a high level risk in stocks, but fixed deposit gives me a very low risk. And should always remember there is a simple relationship between risk and returns. Okay, we say the amount of risk that you take, okay, you get returns exactly for the same amount. That means if you take more risk, you will be rewarded more. If you take less risk, you will be rewarded less. So we are trying to keep a mid-level risk. So we are aiming for a certain returns. So what we do is we try to maintain that rate of return. So let's say for a mid cap, we are expecting 15% returns. Okay, 15% per annum returns. This is what we are expecting. Okay, so I'll say majority time my returns are going to be 15%, but it can go as high as, let's say, 18% and as low as 13%. Okay, so this becomes my range and I can figure out the probability. Let's say the probability of this happening is 0.8, probability of this happening is 0.15, and probability of this happening is 0.05. So from my past performance of the mutual fund, I am saying majority time the rate of interest remains 15%, but sometimes it might go as high as 18%, it can go as low as 13%. Okay, I assume this to be discrete, but you can assume them to be continuous as well, and take a probability distribution. But what I'm trying to say here is that this variable rate model, we try to actually achieve similar type of results in a mutual fund. We try to keep the same level of returns, because we know that if I want to keep same level of risk, I will get same level of returns. So each year we are trying to replicate the returns of the previous year, if we assume that we achieve the correct rate of interest, right? So each year the rate of interest might be slightly different from the previous year, and it might be independent, although it may not. Last year the mutual fund did well, so maybe the manager has confidence that my strategy is working, so maybe this year he will also have a better result, right? That may also happen. But we'll assume that the rate of interest are independent of each other, and also they are identical. That means the same distribution I will expect for I1, I2, I3 as well as IN. For each rate of interest, the distribution remains same. It can be a discrete distribution, it can be a continuous. Right now we are not dealing with a continuous distribution. Later on we'll see continuous distributions as well. Okay. So if the amount of investment that I see each year, okay, so let's say each year I'm investing a certain amount. So let's say I'm investing P0 at time 0, investing P1 at time 1, P2 at time 2, and so on. I'm investing a certain amount at a certain time. Then I'll say that I'll have a certain money after certain number of time. Okay, so I'll say at time 0 I had 0 rupees, or let's assume I had certain money. Okay, so the fund, I'll say F0. I had, let's say, some money in my account at time 0. I invested P0 in this mutual fund. So after 1 year, just before I invest this P1, I had fund F1. Okay, actually just after, let's say just after. Okay. Then similarly, after second year, I have fund 2. After third year, I have fund 3. This is the fund amount, total rupees that I have in that fund. Okay, so n minus 1 Fn. Okay, how do I model this? How do I model this? I would say fund at time 1, okay, or let's say I'll start from fund 0. Fund 0 is nothing but the amount that I invested at time 0. Okay, at time 0 I invested P0, and that is the amount that I have, that is the fund that I have at time 0. Then if I try to model how much I have at time 1, okay, how much do I have at time 1? Okay, just give me 1 second. Okay, I'll be back. Okay, so let's assume that where were we? Variable rate model. So now what I'm assuming is, okay, fund 0, that is before I paid this amount P0. So let's assume at time 0 fund 0 was 0. I had nothing in the account. Then at time 1 I paid the amount P0. So at time 0 I paid the amount P0. So at fund 1 I'll say is going to be nothing but 1 plus I1, the rate of interest that I earned, into P0 plus let's say F0. So the total amount that I had at time 0 will be accumulated for 1 year and gives me fund at time 1. Similarly, if I want to model what is the fund at time 2, it would be 1 plus I2, the rate of interest that I earned, into P1 plus F1. The fund that I had at time 1 before I paid the premium P1. Then I paid the premium P1. So this is the total amount that I have. Then I accumulated it for 1 year to get fund at time 2. So similarly, a general term, fund at time n would be 1 plus I n into P n minus 1 plus F n minus 1. This is how we write this general term for a variable rate model. Okay. So any problem here? This is the general term. Now, if I take an example, let's say we'll talk about single payment. If I assume a single payment or single investment, let's write single investment. So we are saying we have a single investment of rupees 1 invested at time 0, and we are finding the accumulated amount at time n, and we'll write that as Sn. Okay. So if I have a single payment that was invested at time 0 and we are finding accumulated amount at time n, I'll just say Sn would be first year I got the rate of interest of I1. The second year I got the rate of interest of I2. Third year I got the rate of interest of I3, and so on till last year I got the rate of interest of IN. So I'll have multiplication of all years accumulation factors. We can also write this as pi. Pi is used for product 1 to n. Okay, too many i's. So let's say k. K. Any problem here? So I have a single payment at time 0. So at time n, the value will just be 1 plus I raised to n. But because the rate of interest is different each year, I'm just multiplying 1 plus I1 into 1 plus I2 into 1 plus I3 and so on. So this is how we'll model a single payment. We can have an, okay. So for this single payment, if let's say I make a single payment each year, that will become an annual payment. Okay. So if I have annual payment, I'll write it as AN. Okay. So here we are again finding the future value or the accumulated value. Okay, so we'll again say accumulated value of annual payments rupees 1 the start of each year for n years. Okay. So we are talking about accumulated value of annual payments of rupees 1 at the start of each year for n years. So if I just draw the timeline, I'm saying start of each year so the first payment would be at time 0, second payment would be at time 1, third payment time 2 and so on. We are talking about payments in advance. Payments in advance. And we are finding the value here. This is what our value of AN will be. The future value at time n. So you can say that the first value will be accumulated for n years. The second value I will accumulate for n minus 1 year. The third value I will accumulate for n minus 2 years and so on, right? I will accumulate each one of these values till time n to get the accumulated amount or to get the future value. But the rate of interest each year is different. Here I have I1, here I have I2, here I have I3 and so on. This would be IN. Each year the rate of interest is different. And that is why my first payment that was at time 0, say AN, would be first payment I'll get 1 plus I1 into 1 plus I2 and so on till 1 plus, I'll write let's say n minus 1 into 1 plus IN. So this is the first payment only. It has been accumulated for n years. But if I take the second payment also, I'll add up the second payment. It will start from I2. Okay, because it is at time 1, the first rate of interest we'll encounter is I2. And it will be accumulated for n minus 1 years. Similarly, the next payment will start from 1 plus I3, go till the end. And so on. Similarly, I'll have second last payment will go for 2 years. and the last payment would go for 1 year. So it is basically a single payment that is going each year for n years. Now let's assume that we have the distribution of IKs. Okay. So we have the distributions of IKs. So let's assume that expected value of IK is equals to J, okay, J, and variance of IK is S square for all years n. So for all those n years, we are assuming they are independent and identically distributed, right? IIDs. So we are assuming their mean is J and their variance is S square. Okay. Using that, we are going to find moments of Sn. So for a single payment Sn, let's find the moments of that Sn. So we'll say Sn raised to k. Sn raised to k will just be multiplication I going from, not I, sorry. Okay. I'll just write R here because I had written K here for this, right? IK. So I'll write R here. So K is equals to 1 to N 1 plus IK raised to R. So this is what a moment of Sn would look like. So basically moment of X, we'll say X, then X square, then X cube, especially if we take expected values, right? These are the moments of X. So similarly, we are making a general term for moment of Sn. Now we'll find the expected values. Okay. So I'll say expected value of Sn, first moment, will just be multiplication, expected value of multiplication I going K going from 1 to N 1 plus IK. Now because they are all independent, okay, these are all independent of each other, 1 plus I1, 1 plus I2, 1 plus I3 and 1 plus IN. Because they are all independent of each other, I can give individual expectations and say this is pi K going from 1 to N. So expected value of 1 plus IK. Because they are independent of each other, I could give them individual expectations. Then 1 plus IK, we know expected value if we have a constant added or subtracted. What will we get? We'll get 1 plus expected value of IK. And expected value of IK is J. because they are all identical. Every j is exactly same. So expected value of Sn will just be 1 plus j raised to n. So for a single investment at time 0, the accumulated value at time n is just 1 plus j raised to n. That means we are using fixed rate model, right? Remember, this is what we get for fixed rate model. If we assume that we are using the expected rate of interest, j is the expected rate of interest for all years. So this is a variable rate model. This is not a fixed rate model. It's just the expected value of a single investment turns out to be same mathematically. Let's find the variance. For that, I'll need expected value of Sn square. So I can say this is pi k going from 1 to n. Expected value of 1 plus ik square. Any problem here? Okay. So I can expand this 1 plus ik square. I can give individual expectations. We know expected value of ik is j. We can find this expected value of ik square from the variance. We can say variance of ik would be expected value of ik square minus expected value whole square. That means expected value of ik square can be written as variance, that is s square, or variance, that is s square, plus expected value of ik square, that is j square. So you can use that here. We will have 1 plus, okay, this was 2 here, right? So 1 plus 2j plus, let's say j square plus s square, or I can say it is 1 plus j square plus s square, the whole raised to n. 1 plus j square plus 1 plus j the whole square plus s square, the whole raised to n. Any problems here? So we got the mean, we got the expected value of s square. So first moment as well as the second moment. We can use that to find the variance. Okay, so it's basically 1 plus j raised to n whole square. So I can just write it as 1 plus j raised to 2n. This is going to be the variance. Now it's very important for us to remember the mean and the variance of single investment, because we are going to use that directly in sums. We get direct sums. Let me just find a sum. It's page number 9 question. So I hope you have written this much. So the mean and the variance are important. So this is the question. Calculate the mean and the variance of the accumulated value at the end of 25 years of an initial investment of 40,000 if the annual rate of returns in year K is independent of that in any other year, and IK is given as a gamma distribution. So first thing, IK follows gamma 16, 200. Let's find expected value and variance of IK. So for a gamma distribution, the expected value is alpha by lambda. So it would be 16 by 200. That's just 0.08. And variance, okay, so expected value, we'll write it as J. J is 0.08. And variance would be alpha by lambda square. So 16 by 200 square. So that is basically 0.0004. And that becomes S square. So the investment is going for 25 years. The investment is going for 25 years. That is why we'll be finding S25, because we have a single investment. So single investment going for 25 years. That would be pi of 1 plus IK the whole raised to 25. Actually, sorry, not this. K going from 1 to 25. This is how our single investment will go for. You don't need to write this. I just wanted to show you. We don't need to write this. We'll just say that expected value of Sn is going to be 1 plus j raised to 25. That would be 1.08 raised to 25. So because we had 40,000 invested, so expected value of 40,000 Sn will just be Similarly, if you want to find variance of Sn, this is our variance. Any issue here? Mean and variance. Of course, we'll multiply by 40,000 square. Okay, so we'll say variance 40,000 instead of Sn. Okay, instead of Sn you can write S25 because n is 25. Even if you write Sn everywhere, you can just write n is equal to 25 at the beginning, and that's fine. We understand then what's going on. So always when a constant comes out of the variance, it comes out as square. Don't forget that. Don't make a mistake there. So it's a very large value. You can see 124.337 into 10 raised to 28. Okay, it was 40,000 square. So in such cases, we'll write our variance in terms of root. I'll take root and then I'll write it as a square. Again, it's a very large value. Okay. Let me just confirm, did I do it correctly? Did I read the question correctly? Sometimes that happens that we don't read the question correctly. 40,000. Yeah. Everything is fine. Let me just check this. Yeah, I think there might be a mistake. I'll check that equation. 08 raised to 25. Okay, here's the mistake. I wrote raised to 25. It should be raised to 2. Okay. No. Okay, not here. This is raised to 2. I wrote here 25. Okay. So bracket, I'll have 1.08 raised to 2. Then plus 0.0004 bracket close. Then raised to 25. And minus 1.08 raised to 50. Yep. So 0.403765. This is what the variance is. Now we'll multiply 40,000 square to it. Okay, it's a very large number. I should write it as the root answer. So that is 25417 square. This is how we'll represent the variances. Any problem here? So this is how we find mean and variance of a single investment. But what about annual payments? Let's talk about moments of AN, annual investment. Okay. So we said AN is nothing but addition of multiple single payments. Okay, so I'll just copy this part. This is what we had. Now if I want to write let's say A instead of AN, let's say I'm writing AN minus 1. So what's happening is everything is same, but I'm going to just N minus 1. That's the only difference. I'm going only till the amount till the time N minus 1. Right, this is how we'll write AN minus 1. So if I compare this, the only difference is that this 1 plus IN has been removed, right? That's the additional thing. The rest is exactly same. And of course, there is a difference of one payment. Okay, there is a difference of one payment. I'll say AN is 1 plus IN into 1 plus AN minus 1. So payment at N minus 1 plus the fund at N minus 1 into 1 plus IN will give me AN. This comes also from FN was 1 plus IN into PN plus fund PN minus 1 plus fund at N minus 1. This is exactly the same thing. Just the amount that we are investing each year is just 1. Okay. And the fund is written as A. It's the same thing. So we are going to use this relation to try to find the expected values. Okay. So first thing we will be assuming, okay, so let mu n be equal to expected value of AN. So this is the symbol that we are writing, and we'll introduce another symbol MN, that would be expected value of AN square. So we're introducing these terms so that we can make the formula a little easier. Now also if I write A1 is going to be 1 plus I1 into 1 plus a0. a0 I am assuming is 0. So this is just 1 plus I1. So expected value of A1 would be 1 plus expected value of I1. Expected value of I1 is just J. So expected value of A1 just becomes 1 plus J. We will write that as mu1. We'll write that as mu1. Okay. Next, expected value of A1 square. Expected value of A1 square will just be expected value of 1 plus I1 square. So we did this before. This is going to be 1 plus 2j plus j square plus s square. This is what we get. This we will be writing it as m1. So we have mu1 and we have m1. We'll also have a general term of mu(n). Now here if I take the expected value, okay. So if I take the expected value, say expected value of an will be equal to 1 plus expected value of in into 1 plus expected value of an minus 1, or you can just write it as mu n will be equal to 1 plus j into 1 plus mu n minus 1. So with this relationship we can find mu2 using mu1. We can find mu3 using mu2. We can find mu4 using mu3 and so on. Right? I can say that mu n is 1 plus j, 1 plus, I'll substitute mu n as 1 plus j into 1 plus mu n minus 2. Right. Similarly, can say this becomes 1 plus j plus 1 plus j square plus I'll have another 1 plus j into, okay, no, not like this, plus j square into 1 plus to 1 plus mu n minus 3, right? This is how you can keep on going, and you will find that this is nothing but 1 plus j plus 1 plus j square plus 1 plus j cube and so on till 1 plus j raised to n. Now have we seen this pattern before? Have we seen this pattern before? Tell me. What can you make out of this pattern? What would you call this? Everybody has seen, everybody has cleared CM1, right? And that is why you are studying CM2. So have we seen this pattern in CM1? What would be 1 plus I plus 1 plus I square 1 plus I cube till 1 plus I raised to n b? What will this be? This is going to be S due n. This is S due n. So this is also S due n at the rate of j. So expected value of annual payments for n years can be written as S due n at the rate of j%. Okay. Now I had an. Okay, this is my an. If I square this, I'll get an square is 1 plus in square 1 plus n minus 1 square. Let's expand this. Now if I want the expected value, that would be m2, expected value of an square. That would be mn, sorry. That would be mn. That becomes 1 plus 2i would be 2j plus j square plus s square, right? This is what we get for this. And then 1 plus 2an minus 1 will just become 2 mu n minus 1. And this is just, this would be n minus 1. So m n minus 1. So again, if we know mn minus 1, we already know all mu's. We found the relationship of all mu's. So mu n is S due n. So mu n minus 1 would be S due n minus 1. And so on. So basically we found all the mu's. Using that, we can find mn if we know mn minus 1. If we know mn minus 1, then we'll be able to find it. And then use that to find the variance. So variance an, the expected value of an square minus expected value of an the whole square That would be mn minus mu n square. Any problem here? So again, these are very important. We directly get questions for these. Let's see. This is page number 12 question. A company considers that on average it will earn interest on its fund at the rate of 4% per annum. However, the investment policy is such that in any 1 year the yield on the company's fund is equally likely to take any value between 2% and 6% for both single and annual premium calculation with the term of 5, 10, 15, 20 and 25 years, the single or the annual investment of 1. Find the mean accumulation and the standard deviation of the accumulation at the maturity date. So equally likely. Okay, so they are saying that a company considers that on an average it will earn an interest of 4%. So on an average, so average rate is 4%. Okay. However, the investment policy is such that in any 1 year, the yield of the company's fund is equally likely to take any value between 2% to 6%. Okay, equally likely to take any value. So I'll say IK just follows uniform distribution between 2% to 6%. It's equally likely. That means it's a uniform distribution. Using that, we can calculate S square. For uniform distribution, it would be B minus A square by 12. So that would be 4 square by 12. So 4 by 3 percentage. You can write it in terms of decimal places as well. Okay, percentage will be divided by 10,000. Right? Now we have found a J and S. Now we have to find the mean accumulation and standard deviation for single payment as well as for annual investment. So first, let's talk about single payment. So if I say single investment, for a single investment, we'll do 5, 10, 15, 20, 25 later. Okay. First, let's just make a simple formula. So we know expected value of Sn is just 1 plus j raised to n. and variance of Sn is going to be okay, and standard deviation will just be root of the variance. Standard deviation just take root of variance. So now we can easily find the expected value and the standard deviation for each one of those values. So n is 5, 10, 5, 10, 15, 20, 25. I'll directly calculate standard deviation. Calculate these and write in the table. So the J, rate of interest, was 4%. So raised to 5. Okay. Standard deviation. Okay. So you can see the variance formula. We had S square as 4 by 3. We had S square as 4 by 3. Now one more thing we can do is, rather than calculating this for each one of the values of n, I can make just a formula and use table mode to find all of these values. I can use table mode. What I'll do is, say mode table, I'll write the formula here first. So bracket 1.04 square plus bracket 4 by 3 bracket close square bracket close, and this would be raised to, I will use the x value. X would be shift and closing bracket, sorry, not shift, alpha and closing bracket. Alpha and closing bracket will give me x, right? And then minus 1.04 raised to, I want 2 alpha or 2 alpha x. This is my equation. Tell me any problem here while making the equation. While making this equation, right? All I have to do is equal to and I will get a start. I will start with 5. I will end at 25, and steps is 5 because the difference between each one of them is 5. So the steps, I'll take it as 5. So this becomes directly my variances. Okay, actually I did not want variance. I wanted the standard deviation. So I'll press AC. I get my equation back. I'll put the brackets at the beginning and at the end and say raised to 0.5. That becomes the root. Then equal to. These are the nothing but the standard deviations. I may have made a mistake. I'll check. Okay. Yeah. I made a mistake because S square is 4 by 3 percent. Okay. S square is 4 by 3 percent. That just means it is 4 by 3 into 10 raised to minus 4. That's the mistake that I made. Okay. So what I have done here is I've used this equation, okay, and put that directly in the table mode. So I'll show again. I'll start from, this was our math mode. We'll go to table mode. So that would be mode, and in your calculator it would be either 7 or 3 or something. You will find table. We'll go to table mode. You get f of x. Now we want to write this equation. I want directly standard deviation. I directly want standard deviation. So I'll make this equation such that my n is the variable x. Instead of n, I am putting the variable x because I am changing the values of n. So I'll say one bracket, then another bracket, 1.04 raised to 2, and then plus for s, I'll say it is 4 by 3 into 10 raised to, now see, you actually have directly a button in your calculator for 10 raised to. Here it is written exp. This exp also means 10 raised to, and in your physical calculator you will find the 10 raised to button here. Okay, so you can directly do it, but I'll just write 10 raised to minus 4 square, first bracket close, and minus 1.04, sorry, raised to, I'll press alpha and closing bracket. When I press alpha and closing bracket, I get x. Okay, because I want to make this equation in terms of x, and I will change these values of x to directly get these answers. Okay, so raised to x. So how do we make this x? Alpha and this closing bracket, you will find this x written in purple here. Alpha and closing bracket gives you x. Then come down, it's minus 1.04 raised to 2 times x. So again alpha and closing bracket. This becomes my equation. This is my equation here. I'll close this bracket and put raised to 0.5. That means I'm taking root so that I directly get the standard deviation. So that I directly get the standard deviation. I press equal to. Gx will not put gx. We'll just directly go equal to. And start. Now we will say the start number is 5 and equal to end. End number is 25. Equal to steps. Steps just means what should be the difference between each number. So difference between each numbers is 5. So step is 5 and press equal to. So see, you can see here x is 5. They have given the value of f of x. X is 10. They have given the value. X is 15. X is 20 and x is 25. So I don't have to write this equation again and again. It already substituted 5, 10, 15, 20 and 25 for me and gave me the answers. Is that clear now? If you are giving examination from IFOA, you can use Excel also to do the same thing. It's not very complicated. You can use Excel, make the equation and quickly get these values. Now, of course, this is for our understanding. They will not directly ask you to do it for 5 years, 10 years, 15 years, 20 years and 25. This is more of for our understanding. So this is what a single investment, expected value and standard deviation will look like. But when I am talking about annual payment, annual investment, we say the expected value for AN, we'll write it as mu n. That would be S due n at the rate J% for J%. And variance of AN, we say it is Mn minus mu n square, where Mn is, so we wrote the formula for Mn here, right? This is our Mn. So that is basically 1 plus, you can write 1 plus j square plus s square. 1 plus j square s square into 1 plus 2 mu m minus 1 plus m n minus 1, n minus 1, n minus 1. And of course, standard deviation will just be root of variance. Now, this is complicated and they will not be asking you in the examination, but the best way to solve this would be using Excel. This, at least this variance part, will be easier to solve using Excel. Otherwise you will have to do a lot of calculations by hand, and I'll talk about it why. We can find expected value very easily. You can say for n 5, 10, 15, 20, 25, my expected value of AN, that is also mu n, that is also written as mu n. I can find that very easily. It is S due n. S due n at the rate J%. J is 4%. So 1.04 raised to 5 minus 1 upon, it's going to be d s du n, denominator will be d, that is 0.04 divided by 1.04, that is the d part. I'm rounding it up and it's becoming 1.633. Then I'll change this equation. Instead of 5, I need 10 now. I'll change this equation again. Where's my equation? Change this equation, and from 10 I'll go to 15. $20, 25, so for standard deviation, we will need, we'll need mn to calculate variance. For calculating mn, we required mu n minus 1. So if I'm calculating for 5 years, that means I'm calculating m5, I will need mu 4 as well as m4. Mu 4 is very easy. Mu 4 we can calculate very easily. But to calculate m4, you will require mu 3 and m3. For calculating m3, you will require mu 2 and m2. For calculating m2, you will require mu 1 and m1. For calculating m1, you don't require anything because m1 will actually be, where is it? Okay, I think we did not write m1, but you can substitute here m1, and what do we get? Mu 0. Mu 0 will be 0 and m0 will also be 0. So we'll just get 1 plus j square plus s square, that is m1. So to calculate m5, you will require m4, m3, m2, m1. So similarly, mu also you need all values. So you can imagine for calculating 25, you will require all of those values as well. So in such cases, doing it by calculator would not be possible. Okay, it will be very lengthy. So let's do it using Excel. It will be very easy to do it with Excel. Okay. So first of all, the number of years I'll require for all of them. I'll write a few things. I'll write j value 0.04, and s square value would be equal to 4 by 3 into 0.0001. So 10 raised to minus 4. Okay. That is what our s square is. For now, I just need that values. Go from n. Okay, I want to go for 25 years. I want to go for 25 years. Then the few things that we'll require, first is the mu values. So mu would be S du n. Okay, so S du n, it is equal to bracket numerator, another bracket 1 plus the j is 4%, I will fix it, bracket close, raised to n minus 1, bracket close, that's the numerator closed, divided by, I want d in the denominator, that is same as j, fix it, divided by another bracket 1 plus j and fix it. Okay, so I'm making the exact same formula that I made while I was calculating the mu for those 5 years, but now we want mu for all 25 years. That's mu. Then we'll require the m values, m. So for the first year, we know m is going to be 1 plus j square plus s square. Okay. 1 plus j square plus s square. So equal to bracket 1 plus j raised to 2 plus s square is this. That becomes my m for first year. Now for m for second year, m2, what will it be? Now you can see in mn formula, I want this 1 plus j square plus s square multiplied to each one of them. So I can say that is just m1. This is m1 into 1 plus 2 mu1 plus m1. Okay, that is what I would need here. So I can say is equals to the previous value. I will fix this because every time it is going to be m1, right? I'll just show you here. If I want m3, this will also be m1 into 1 plus 2 mu2 plus m2. Similarly, m4 will still be m1 into 1 plus 2 mu3 plus m3 and so on. So this m is changing, but this m1 is not changing because it's a constant value. This is what we are multiplying every single time. So here I'll say equal to this value, fix it, multiplied by bracket 1 plus 2 into m1, the previous value, sorry, mu1 plus m1, the formula that we'll make, and then drag it till the end. These are all the different m values. These are all the different m values. Using that, I'll directly make SD, standard deviation, would be equal to square root is SQRT, square root of m minus mu raised to 2. Okay, m minus mu raised to 2 is going to be the variance, and taking square root of that gives me standard deviation. So directly I've got standard deviation. I specifically want only year 5, 10, 15, 20 and 25. If this was an Excel paper, I would have used goal seek. Would have said n is 5. not goal seek, sorry, VLOOKUP, right? 15, 20, 25. I would say mu values and SD values. So for mu values, I would say equal to VLOOKUP. Everybody, I hope, knows what VLOOKUP is. VLOOKUP we use to find specific values. So here we want n is 5, 10, 15, 20 and 25. So we want to look up this value, that is n is 5. From the table array, comma, to give the table from which I want it to look. So let's say this is my table array. I just want the mu value, comma, the column should be 2. Second column, my answer should be the second column. This is the mu values. And comma, I'll put false. Okay, because I want exact match. If I want exact match, I'll write false. Now one thing you should always do is, this is the table array. I want to fix it because I'll drag it down later on so that I get different values. So I should fix this table array. This. So fix the table array. Enter. Now I drag it down. I think these are the exact values that we got. Yes, these are the exact values that we got for the mu values. And for SD, I'll do the same thing, equal to VLOOKUP. VLOOKUP, I want to look up this value, comma, from the table array. This is my table array. I want to fix it. I'll press F4 and it will fix the both starting and the end of the table array. Comma. I want the column. I want the fourth column now. This is the first, second, third and fourth column. So the answer is my fourth column. Comma. False, because I want the exact answer. I don't want approximate answer. These are the 5 values. This is how I would have done this question if they would have asked in the examination using Excel. Right now I'll just write down the solutions. SD. So finding variance for annual investment is complicated, but using Excel it will become very easy. Okay, any problem here? For today we'll leave it here, not go to the next topic, because I guess, yep, it's log normal distribution. So for the next topic we require the knowledge of log normal distribution. By any chance, if you don't remember log normal distribution, please go to your CS1 notes and read about it again. Okay, how do we log normal distribution? We don't need the PDF of log normal distribution, but we'll need the expected value, variance and the relationship with normal. How do we find probabilities? Finding probabilities will be important, relationship with normal will be important, expected value and variance of log normal distribution. Okay, because those things will be important here to study the next part. So any questions? Any doubts? If not, we'll meet next week. Okay. So next Saturday we'll meet and we'll continue this. Bye. Welcome. Bye.